So case 4, underdamped system. So it takes little time. This is one of the lengthiest derivation but not difficult. Many books have given different derivations, but I try to make you easy by following the simplest method, which we had adapted for the previous derivations also. So please, no need to write the notes, okay, because may take more time. So I'll be a bit faster. And once the internal gets over, you can refer back the video again and practice this derivation. So for time being, just look at this video, and whenever you get any doubt, you can ask me. So we start with the fourth case, which is underdamped, where zeta is between 0 and 1. It is positive. So I hope everyone have got an idea why zeta cannot be negative. Or if zeta is negative, what does it implies with respect to system dynamics? Okay. So we cannot have a negative zeta. So negative zeta reflects that like one of the element is having a negative value, which is not possible. So directly start with the derivation. We know that C of s by R of s, the standard second order transfer function, which is omega n square divided by s square plus 2 zeta omega ns plus omega n square. So we already knew that zeta equal to 1 was critically damped case, but for zeta between 0 and 1, we cannot make any substitution directly in the transfer function because there are infinite possibilities that zeta can have any value between 0 and 1. So I hope everyone agrees with this. We can have infinite values for zeta between 0 and 1. Infinite possibilities. So our derivation is quite difficult here at this point of time because we need to make a generalized derivation now. So all the previous derivations were upon substitution and hence those steps were easy, but here it is quite tricky. So one thing is clear, we cannot substitute zeta, without that we'll proceed. So we already know that the roots are given as minus s1 equal to minus zeta omega n plus j omega n square root of 1 minus zeta square. So j appears because zeta is between 0 and 1. And the second, okay, sorry, minus. Second root is minus s2 equal to minus zeta omega n minus j omega n square root of 1 minus zeta square. So let minus s1 and minus s2 together represented as minus alpha plus or minus j omega d, the two roots of the second order transfer function. I hope everything is clear till this point. The next step is, without any doubt, substitute the input Laplace as 1 by s for unit step function, and rewriting the previous equation 1, we get omega n square divided by s plus, now I will rewrite in terms of roots. Rewrite in terms of roots, therefore it is s plus alpha plus j omega d, and other root is s plus alpha minus j omega d into 1 by s. Okay. So to find c of t, one has to take the inverse Laplace of equation 2. Equation 2. So directly apply partial fraction for this. So I'll make it clear to you, there is no unique way of deriving the things, whatever I'm doing now. Okay, there's no unique thing. You can follow my step, and if you find easy, you can use this, or you can follow any steps given in the textbook or in any other material. Okay, but make sure you end up with the same answer, whichever the method is. So that's what I need. So now we'll apply partial fraction omega n square divided by the denominator, same as this, equal to a by s plus b divided by s plus alpha j omega d plus the third term c divided by s plus alpha minus j omega d. The three terms. You can stop me if there is any mistake, but I suggest you to wait and watch. So now I'll take the common factors. So this one is s plus alpha whole square, and this omega d is with negative sign, so it is as good as a square minus b square or a plus b into a minus b form. So I'll replace that to a square minus b square, So j square will vanish the negative sign. We will get plus omega d square. So j is not present here. So converted to j square. Then similarly b will be bs into s plus alpha minus j omega d. And c is cs s plus alpha plus j omega d. So to find constants a, b, c, now first step, substitute s equal to 0. S equal to 0 in this expression, we get omega n square equal to a alpha square plus omega d square, s is 0. Similarly, b and c will automatically be 0. So a is equal to omega n square divided by alpha square plus omega d square. But we have made a substitution for alpha and omega d. Okay, what all we have assumed? You can see here minus alpha is minus zeta omega n. Therefore, alpha is zeta omega n. Similarly, omega d is omega n square root of 1 minus zeta square. So substitute that before proceeding. Okay. Remember this definition. So what do we get after substitution? It is omega n square divided by alpha square is zeta square omega n square. Then omega d square is omega n square root of 1 minus zeta square whole square. Or omega n square divided by zeta square omega n square plus omega n square minus zeta square omega n square. It's very simple. So zeta square omega n square will cancel and omega n square divided by omega n square is equal to 1. So the first step a is equal to 1. Next, how to find b and c. So again there are different steps or methods you can follow, but if your mathematics is correct, we both will end up with the same answer. So I'll follow the previous steps. Substitute s equal to 1, omega n square equal to. So observe carefully, we already have a equal to 1. So I'll replace a by 1 and then proceed. So it is 1 plus alpha square plus 2 alpha, because it's 1 plus alpha whole square plus omega d square as it is. Then we have a b term plus b. Look at this carefully. Then plus b into alpha. Then minus b into j omega d. Plus again c into s is c into 1. Then c into alpha minus, plus c into j of omega d. Then second one, substitute s equal to minus 1. We have omega n square equal to 1 plus alpha square minus 2 alpha it is now, plus omega d square as it is. So s equal to minus 1, we have two s's here, inside bracket and outside bracket. Therefore, minus and minus is plus b. Now it is minus b alpha and plus b j omega d. Similarly, c minus c alpha and minus c of j omega d. So these are the two different equations which we have to solve for b and c. So there may exist simpler techniques than what I am doing also. You can follow that also. But some students need a detailed explanation for derivation. That's why I have chosen this method. And if once you get familiar with this, automatically you can develop your own simplest method. That is also possible. It looks lengthy, but I have told you the reason. So first is add both the equations. So 1 plus 1 is 2, alpha square 2 alpha square. Some terms will get cancelled. Omega d square will get added, b will get added, b alpha will get cancelled. Then bj omega d will get cancelled, c will get added, c alpha will get cancelled, and c of j omega d will also get cancelled. And 2 is a common element in the equation. You can cancel out the 2. And you can make a replacement for alpha and omega d now itself. So omega d we already know, and omega d square is also known. Omega d square is this one. We did it in a previous step. So omega d square is this, and alpha square is zeta square omega n square. So when you simplify and substitute, plus and minus zeta square omega n square will cancel, and RHS LHS omega n square will get cancelled. So what we have is one constant b and c. That's it. So this is 0 equal to 1 plus b plus c. Sorry, 1 plus b plus c, or b plus c equal to minus 1. Now subtract the equation. So we are proceeding towards finding c of t. Everyone should keep that in mind. So next is the second method, the second option. Subtract this star and double star equation. Okay. So I'll write a direct equation cancelling out the common terms and elements. So we have to add 2 alpha, which will become 4 alpha. Since it is 2 will be common in that, I have removed that. Similarly, b alpha, and then bj omega d, then c alpha, cj omega d. These are the terms we get. I am skipping this one intermediate equation, one simple intermediate equation like this, and we'll end up with the next step equation. So I'll make a substitution of b in this equation from the first one. So I'll replace wherever b is present with minus 1 and minus c. Then it's not as complicated as we think, very simple. So if you substitute for b, and then all the terms here are with c except this, then take c as a common element, then rearrange this equation, we will directly get the answer for c. So I will hold for 1 minute. If you want, you can write down only these equations, this equation and this equation, and please try to get the expression for c. You can try it out. I'll just give 1 minute because they're very simple equations. Okay, so then please compare your answer with my answer. This is what you get after simplifying. Okay, minus alpha minus j omega d divided by 2j omega d. And what is b? B is minus 1 minus c. So just replace all that. Sorry. So minus 1 minus 1 is as it is, minus c is minus of these terms, so it will become plus alpha and plus j omega d divided by 2j omega d, or b equals to simple mathematical steps, whole divided by 2j omega d, that is equal to alpha minus j omega d divided by 2j omega d as it is. Okay, so we got b also, we got c also, and we already know what is a. So all the constants are known now. What is the next step? So straightforward, substitute ABC, whatever you got, in this equation. Okay, let me rewrite all those values again. Then make the substitution. So C of S equal to A is 1 by S. B is alpha minus j omega d. Then divided by 2j omega d into 1 divided by S plus alpha plus j omega d plus substitute the C minus alpha minus j omega d divided by 2j omega d 1 plus 1 divided by S plus alpha minus j omega d. Okay, so that's it. That's what we get from the above equation. So the other reason why I have chosen this particular method is this derivation covers some concepts of mathematics that we can revise and will help for the future study also. I mean the next chapter. So is it fine? Yeah, that should be fine. So the next thing is directly apply inverse Laplace. So keep the constants as it is. Alpha minus j omega d 2j omega d into the inverse Laplace of the term present here. It is e raised to minus alpha minus j omega d. Okay, this whole term I will take it as s plus a something a. Then keep c as it is. Then take the inverse Laplace for this also. So it's minus alpha but plus j omega d now. Okay, into t, sorry. I forgot in the previous expression. Minus alpha plus j omega d into t. T should be multiplied here also. Clear? So you can take this as s plus a. And we have a with this term now. So it will become e raised to minus 80. So minus alpha minus of minus will be plus j omega d dt. So till this point, I think everything should be clear to you. So this is C of t now. Fine. So is it completed now? This is the question. Okay, we have done and we have taken inverse Laplace everything. So mathematically it sounds that if you know zeta and omega n, you can calculate C of t for any time instant, correct? Okay, but you will end up with some complex number without any doubt. So I don't know why when everything is real, why the j, the imaginary term appears in mathematics. So my question is right, fine. So we never pay to a shop person, take imaginary 10 rupees and give me a lace. We always say real 10 rupees. I mean the real 10 rupees and give me the lace. But why this j is coming into picture? Does anyone knows why this j appears in mathematics? I hope you have already studied the complex numbers since your high school, I guess. Why things will get complex in mathematics when everything is real is my question. Can anyone answer me? What is the importance of j or I? Okay, I will answer that question soon. So please follow me up. And because of this reason, that the presence of j will make this final expression to look something weird. Okay, it's not like easy to remember, or it's not the way to express, or it's very difficult to interpret the behavior of the system with this equation. That's another reason. So what we do is, though if you feed this equation in the software, it may solve for you, it may give the right graph for you, but ultimately, theoretically also we should express our derivation in a nice form, nice looking form, or a standard form, I suppose say. So we are left with one steps which will convert this final expression into something standard form. So how to do that? Let us see. So we have to eliminate this complex term j. Eliminate in the sense we should make some alternative for that. And also we should express in terms of zeta and omega n, the final expression. So we should replace alpha and omega d also. Alpha and omega d by zeta and omega n. So few more steps are left. So how to eliminate the complex term j is the question. There are many other ways that you can do.
Rationalize denominator, sir.
Yeah, that is one way. But slight modification at this particular stage. Okay, so please follow up. Slightly different approach we are making to replace or eliminate that j. So how do we know the complex numbers? If you have a point in the complex plane given by a plus jb, its magnitude is given by square root of a square plus b square, and the angle is tan inverse b by a. So we call it as magnitude and phase angle. This is a very simplest representation of a complex number. I mean, one of the way to represent a complex number in a complex plane. So if you have a complex plane, we call x-axis as the real axis, y as the imaginary axis, and if I want to locate, say, point P or point A plus JB, so move towards the positive axis of real and move towards the positive axis of imaginary for magnitude A and B respectively. Then plot a line with a magnitude of m at an angle of phi, you will get that point. So that is how we represent complex number in different way with magnitude and phase angle. And parallelly, if we have say another point which is given by minus a plus jb, so real part is negative, imaginary part is positive, so it will be in second quadrant without any doubt. Minus a at this side and plus b on the positive side of imaginary axis. So how do we write the magnitude and phase angle for this? Is it similar to the previous one? Square root of a square plus b square into tan inverse of b by a, or something different? Okay, so the tan inverse of b by a is not the angle. Instead, we should write 180 minus tan inverse of b by a. So okay, sorry. So the second point will lie in the second quadrant, and we have say something theta. Let me call this as theta. Theta, it is not phi. Okay, so this is theta, and phi is this angle. Phi is actually this angle. So how do we get phi? So phi equal to 180 minus theta. Fine. So that's how the complex number with a negative real part is represented. Similarly, we can have two more scenarios, minus a minus jb. It will be in third quadrant, and plus a minus jb in the fourth quadrant. So how to write the angles for third and fourth quadrant? You please understand. So for third quadrant, it is 180 plus theta, and for the fourth quadrant, it is directly minus theta or minus tan inverse b by a. Fine. So let us make use of this complex numbers identity. And we also know angle phi is written as e raised to j phi. E raised to j phi. And one can make use of this in our step. So that was a brief introduction to complex numbers, and we will follow those technique in our simplification step. So I will take this term and rewrite it as alpha plus j omega d by taking negative as common, divided by 2j omega d. Therefore, it is e raised to minus alpha t minus j omega dt. Then I will write this expression here. It is alpha minus j omega d as it is divided by 2j and e raised to minus alpha t. Okay, sorry, that should be plus. This is minus. Yeah. So this equation here, this equation is here. So we are about to finish the final step. Let me take all the terms inside negative sign now. So the first term as it is, and e raised to minus alpha t as it is, e raised to j omega dt as it is. This will become minus now because I have taken minus as a common sign. So minus and minus will give us plus. So alpha minus j omega d, right, divided by 2j omega d into e raised to minus alpha t and e raised to minus j omega dt as it is. So let us look for this first term. I mean numerator of the first term. Alpha plus j omega d has a magnitude of alpha square plus omega d square, and both are positive, so phase angle is tan inverse of omega d by alpha. Tan inverse of omega d by alpha. So replace alpha by zeta and omega n. The same steps which we already have done. Omega d is damped oscillations. So I will call the phase angle as phi for time being. And what is this simplification gives at the end is omega n square into the square root or just omega n. And how do we write phi? Phi is considering these two terms, that is omega n into 1 minus zeta square divided by zeta omega n. Omega n and omega n will cancel. Therefore, we have the angle as tan inverse of 1 minus zeta square by zeta. So please remember what is phi. Phi is tan inverse of square root of 1 minus zeta square divided by zeta. So let this be term A, and let us go for the second simplification. Okay, as I have already told, angle phi can be written as e raised to plus j phi. So now let us go for this term. Alpha minus j omega d. So for this magnitude will remain same, but the phase angle will have minus tan inverse because it is in the fourth quadrant. Negative imaginary axis, positive real axis. It's a fourth quadrant. So magnitude is same as the previous one. Phase angle is just minus phi you can mention. Okay, or it is e raised to minus j phi. So this is second expression for the second simplified term. But still the j term in the denominator is present, so I'll fit it into some other expression. Let us see where we can fix that j in the denominator. Sorry, it's not a, only the numerator is a, and this numerator is b. I hope there is no doubt regarding this. So let us proceed with the previous equation and replace a and b term. So a is omega n e raised to plus j phi divided by 2j omega d as it is. We have e raised to minus alpha t and e raised to plus j omega dt. Similarly, minus omega n e raised to minus j phi into e raised to minus alpha divided by, okay, sorry, 2j as it is, and e raised to minus alpha t into e raised to minus j omega dt. Okay, so we are just one step ahead of final step, final expression. So take the common elements outside. So we have e raised to minus alpha t, we have omega n common, we have omega d common. but for time being, I'll keep 2j in the denominator. So take all the common elements outside, omega n divided by omega d. Omega d I'll rewrite in terms of omega n square root of 1 minus eta square. So e raised to minus alpha t, which is taken as common, I'll replace alpha with minus zeta omega n. And what we are left with? We are left with e raised to plus j phi into e raised to plus j omega dt minus e raised to minus j phi e raised to minus j omega dt divided by 2j. Okay. So how we can rewrite this? 1 minus e raised to minus zeta omega n, 1 minus zeta square, because omega n and omega n will get cancelled. And I will add up all the terms now. So j is common, take it as common, omega dt plus phi, and here it is minus j omega dt plus phi divided by 2j. So now you can will make some sense. I mean, this expression you might have already encountered in mathematics. So it is e raised to minus zeta omega n t divided by 1 minus zeta square. So what is this expression? It is sine omega dt plus phi. Okay. So e raised to j theta minus e raised to minus j theta divided by 2j is sine theta. You can cross verify it in complex number theory. So we are done with the final expression of time domain behavior for underdamped case. So this looks quite simple compared to the previous one, and also the complicated complex j is disappeared. Fine. So this is it, and how we can cross verify. How we can cross verify this now is you can make which one we'll choose. We'll choose a undamped case. Okay. Okay. If you substitute zeta equal to 0, just try it later. You can try it later. If you substitute zeta equal to 0 for a undamped scenario, because we said underdamped is between 0 and 1, and just for the sake of clarification or cross verification, let us substitute zeta equal to 0 in the final expression, and let us see whether we will end up with the same expression as that we had derived in case 3, which is 1 minus cos omega dt, I suppose. I guess 1 minus cos omega dt. Okay, I leave it up to you. Anyhow, substitute zeta equal to 0 and cross verify what expression it will give us. Substitute zeta equal to 0 even in the phi also. I mean, phi is tan inverse of square root of 1 minus zeta square divided by zeta. Verifying that also and cross check. And how the response looks like. How the response looks like is very obvious. I won't be drawing any tabular column or diagram for this now. We had seen the response for underdamped system as decaying oscillations. With the decaying oscillations. Oscillations were present, but they died out after certain time. So the reason is as t increases, this term will vanish. That I have already told. So e raised to say 1000, this will be very, very less, which in turn makes this term to be very less. So the final, I mean the value of c of t at 1000 seconds is almost unity. And the oscillations are caused because of this sine term. So when t is less, also t equal to 0, we will have some oscillations, and t slowly increases, say up to 1 second or 2 seconds. We will have the effect of a sine term, in the response. So we will have a decaying oscillation. Okay, so that's it for the derivation. And please, after internals, please have a look at this derivation again. Practice yourself without fail. Since it is quite lengthy derivation, I couldn't give you time to cross verify the steps. So please cooperate with this lecture. And that's it for today's class. So this finishes only the time domain analysis of only the time domain analysis of all four cases. Okay. So the next part is defining time domain specifications. Time domain specifications